All right, thank you, Gary, for coming to this meeting of the Senior Digital Enterprise Architecture Board. What I want to take this opportunity, as you're considering coming on board as a consultant for the student loans company, is that we want to take the opportunity to stress on you the responsibility that we have for producing systems that will last the test of time. So here at the Student Loans Company, we give loans to students, and we do that because they need to go to university. So that's a really important responsibility that we have. So what we don't want to do is we don't want to mess around with that. I mean, certainly, like, you know, we've all been to conferences. I guess not as much these days. We don't have as much time, and you know, we have people coming back from, like, you know, QCon or GOTO, and they're saying that if only we used, you know, Docker.js mega services on the cloud, then everything would be fine and everything would be just fixed instantly. And we know that that's not true. We know that enterprise architecture is hard. Long-term stewardship is hard, and so we have this system that we urgently need built, and that's why we're looking for help from consultants like yourself, Gary. But we do need to make sure it's done in a responsible manner that is going to really help us work in the long term. And frankly, when you brought up the idea of using Clojure to build this new kind of a system for tracking courses in student loans, I was a bit surprised, because I know we have a lot of problems. I know there's a lot of things that we should be working on. That's the same with any system that's valuable and has existed for some time. But I didn't know that we were using the wrong programming language, and that was one of our problems. So we're really keen to hear you explain why that's something we should be considering.
Chris, it's great to see you again. I think, as you know, my business card says something about being a technology consultant or IT consultant. But in the reality, I just love technology, and I love what technology can do for people. People like the students who depend on the systems that you build to get money for their studies. I also love what technology can do for society. Our society is much better for educated people. But in addition, I love what technology can do for people like you who do want to be responsible stewards for the organization. Now, I'd like to call out just now that I think you have a really tough job. You have a really tough job in an enterprise environment. And that job in the enterprise environment means that you need to deliver business as usual capability while delivering brand new systems. You need to look at the stability of your platform and maintain consistency across all your systems, while at the same time considering new technology. And you have to be able to look at evolving your systems while simultaneously working within the constraints of previous decisions. And that is absolutely not an easy thing to do. So let me just summarize where I think we are at the moment. You have a new capability that you have to build for Student Loans Company. You don't have enough time to build that capability. And Student Loans Company, part of UK Gov, have determined that they want to move towards being a technology centre of excellence. So there is going to be some transformation involved as well. Now, that's one of the reasons why I've suggested Clojure to you. It really does draw a line in the sand of moving on to pastures new and really focusing on bleeding edge technology. Is a tough deadline in the enterprise environment the right time to look at that? Is it the right time for a first foray into functional programming? I don't know, but I'd like to discuss it with you in more detail.
All right, thanks everyone. So I am Chris, and this is Gary, but we, as it happens, are both consultants. So the structure that we're going to use for this talk is to recreate a series of conversations that we've had on a client gig a while back, which was as consultants for the Student Loans Company. So we did have to build a new system. There wasn't much time. And there were genuine and reasonable concerns from the client about what it would mean to use Clojure. So what we want to do today is we want to actually give a fair representation for the other side. Here at conferences, it's very easy to talk about the coolness of the new, but we also have to think carefully as engineers in industry about what the impact our decisions and the things we adopt might have on other people.
in the interest of protecting everyone's identity, we're going to be taking part as Chris and Gary. But needless to say, these conversations have happened in the enterprise environment. So they really are pulled together pieces of many different conversations with many different people to try and outline some of the things that we've found are very important and were challenging, and that sometimes were really, really good and beneficial. Now, I'd just like to give you a wee flavour of how we're going to do this. So we're going to try and be a wee bit theatrical. We're going to break this up into scenes. We have 7 scenes which we feel punctuate different key points about closure in the enterprise and adopting functional languages. And what we're going to do for each of those stages is we'll give you a brief conversation, and then we'll progress on to something like this. Now, rather than keep all this about Chris and I's opinions, we're clearly biased. What we've tried to do is get in contact with people who were involved with the project at technology level, so developers, architects, technologists, and we've surveyed them to see what their feedback was on how successful it was and all the key points that we're going to present to you today. So hopefully this is going to be a bit more warts and all rather than the kind of neophilia that Chris suggested that some people experience perhaps when we attend conferences. So here we have, just as a bit of an example, 2 questions. So I'd like to really gauge everybody's perspective at the start of the talk, and then we can see where we've got to at the end. So these are 2 questions that we put to our previous colleagues. Closure's advantages make it worth introducing into a traditional Java environment, or Closure has some nice features, but it's a little too much to introduce into the traditional Java environment. So it's a pre-lunch session. I'd like to get everybody moving a wee bit, and don't worry, we'll only ask you to do this once. Can I ask everybody to stand up just now, and I'd just like to get a bit of a gauge on exactly where everybody in the room today stands on this question. So everyone, if you could take to your feet for a moment.
Thank you. So the structure of the survey that we gave to our ex-colleagues, both from the Student Loans Company and ThoughtWorks, the consultancy, architects and other kinds of technologists, is we'd present them with 2 alternative statements and ask them which of the 2 they agreed with the most. So we're going to do the same with you to start with. So everyone's standing. So for people who agree with the statement, more than the other one, that Closure's advantages make it worth introducing into a traditional Java environment, if that's already your impression, could you please sit down now?
Wow.
Well, that's good. I like
really
a lot of honest people in the audience.
Yeah.
It's good too, willing to...
So for the people who sat down there, something hopefully we can do for you today is perhaps present some of our approaches and some of the challenging questions you'll have to help you progress Closure into the environments that you work in. So hopefully that's something that you can take away from today.
Cool. So now as a second step, people who are standing, stay standing just a little bit longer. Could people who actively agree with the second statement, that Closure has some nice features, but it's a little too much to introduce into a Java environment, a traditional Java environment, could you sit down now and leave only kind of the people who are on the fence? Oh, that's good.
Wow.
I have to say, I think you 2 are the winners of this, right? Because this is a complex situation. Things like technology adoption, take a long time to actually understand the implications. So thanks for being honest, people. You can sit down now as well.
So for people who sat down thinking that this was perhaps a little too much, hopefully we can convince you otherwise by the end of the talk. And as Chris says, for the people still standing, maybe we can give you a few extra tools to allow yourself to come to a bit more of a conclusion. Cool. So, enough of the amateur dramatics. This is the kind of thing you'll see after each section. We'll present back to the percentage of who swayed in each direction. And of course, we're going to keep this as a cliffhanger for just before the end of the talk.
Sure.
And one final piece of housekeeping. Please do engage. It's very important for us as well as for the conference to make sure that we're getting feedback the whole time. Right. Scene 2.
Scene 2, design. Right, now Gary, I've worked with Java for a long time, and I know it has warts better than anyone else, right? I've lived with them day in and day out for a long time. But the thing that reassures me about Java as a technology choice is we know what those warts are. We've had a long time to discover it. Many, many books have been written about how to deal with those kind of circumstances. You've got the Gang of Four design patterns, you've got Martin Fowler's books, you've got Eric Evans on domain-driven design. There's a whole literature on how to deal with things that are wrong with Java, right? And while I guess to someone who's really interested in the latest and greatest, that might seem like an annoying thing, right? But to me, as someone who's trying to responsibly take care of our systems, that's very reassuring, because I know that we're unlikely to come across problems with Java that haven't happened before, that haven't got a way, a best practice. I know I'm not supposed to say best practice, but a best practice around them, right? Clojure, however, I don't feel like I yet have the same confidence. I don't know what best practice or design patterns are in there at Clojure. I know that, there might be things that we come across that haven't got existing solutions. So that's something that I'm kind of worried about when for picking it for a project that's on our critical path like this. And I just worry as well that, like, I'm going to have teams of engineers who are sitting around reinventing really basic stuff, like, MVC and HTTP servers and things like that, when all I really want is to get to the business problem and solve the business need that I have right now. So have you got anything to say about that, and how, what is best practice in Clojure? How do we get across that?
It's funny you mentioned the Gang of Fours book, Chris. I remember I spent much of my career with that book under my pillow when I slept at night. I've spent a significant amount of time investing in design patterns and understanding them and seeing where they could really benefit the organisations I'm working for. Peter Norvig, Director of Research at Google, actually raised something fairly interesting, that 16 of the original 23 patterns that were raised in the Gang of Four book can be removed with language-level features when you look at languages such as Lisps. Now, if you imagine, in terms of accidental complexity within your organization and within your code base, if you could remove a lot of those design patterns, which quite often, to be fair, I find are incorrectly used on many occasions, then you can massively reduce the complexity, and perhaps you can progress onto something that's a bit faster to iterate on and a bit easier to remove bugs from. Now, on your points about Clojure, Clojure is a functional language, and functional languages are based on lambda calculus. It's been around since the 1930s. They're not new. Functional languages, and Lisps as well, Clojure is in both categories, they've been around since the 1950s. So although the uptake perhaps hasn't been as great as object-oriented programming, there is a wealth of knowledge and information that is already out there in the domain. You're right, Clojure itself is a new language. I think the first release was around 2007. Rich Hickey's come up with a fantastic language, and his intention was to produce something that would really work anywhere that Java would work, but just to be a little bit more concise. There will be a learning curve, I can't deny that. But perhaps we need to consider what is simple, what will produce simple solutions, as opposed to what is easy because you already understand it.
Okay, so this is something that we asked our colleagues about. So on the survey that we sent out to both ThoughtWorkers and student loans developers, we asked them whether they most agreed with the statement that Clojure's flexibility allows teams to design a solution that meets their specific needs. Or on the flip side, whether they more agreed with the statement that Clojure's flexibility draws teams into wasting time redesigning solved problems.
So here's our first big drumroll moment, the first actual survey data that's come from people who worked on the enterprise project. And it's a bit of a landslide.
Right, so you can definitely see that 90% of the people we surveyed who had worked on this project, so had actual contact with it, felt that the flexibility was actually the win. But you can see it wasn't unanimous. So there were reasonable people who worked on the team who actually felt that the design flexibility of Clojure and the fact that it was moving into a new and maybe a little bit less recently trodden path, that did actually make a difference. And I think probably also the people who did, in the end, vote in favour of flexibility being valuable probably did have some misgivings and some thoughts about the flip side as well.
We all know we can make numbers say anything, so what we'd like to do is pull out one or two key quotes that we felt summed up people's opinions. So small libraries allow us to design code around the domain and not shoehorn the domain into the framework. Now, that's quite important for me because Clojure, as many of you I'm sure will know, has a big focus on small, reusable, composable libraries. And that's quite a significant shift from the monolith Java application. But I think it's fair to say from that quote that people were feeling the benefits of really taking advantage of the smallness in there.
Yeah, I guess it's not just about composing functions, about composing libraries as well. The second quote, I think, is also telling, I guess, from the flip side, which is, with a smallish team of skilled practitioners, you can produce really high-quality code pretty fast. So there's a few qualifiers in there that are actually, I guess, the key to the kicker in this, which is that it talks about a smallish team. So in our experience, the benefits of having a small team who really know what they're doing, who really understand each other and are working well together, are magnified by a language such as Clojure, because it does have that flexibility and allows you to shape the language and the design around the domain. On the other hand, I think the effects of having a large team do erode that power. If what you're trying to do with your program is be able to mold it, then having ownership that is weak or distributed across many people makes it hard for any one person to feel like they can take control and crank out that really innovative but suitable for that context design.
And the part about skilled practitioners I think is quite important as well. We did have a really strong team of developers. They were really effective and they really made this work. The reality is, perhaps that group of people could have made pretty much anything work. Maybe they could have coded it in Excel, I don't know. But they were a really strong team, and that's important to bear in mind. Although over a period of time, there was more and more people getting involved from wider areas of Student Loans Company. And it was interesting to see their interaction and the outcomes from their experience.
Cool, all right. Scene 3, hiring. So, I understand, Gary, that you've explained some of the technical merits of Clojure, and these make sense to me as someone who's studied design for a long period of time. But as someone who's worried about the long-term health of the system, I can't afford to just concentrate on the technology, right? So for this to continue to live and grow and face the new modifications that will come in when government changes policy on education, what we need is people, right? And we need them, frankly, at affordable prices. So what I'm worried about is that I know that there's many, many Java developers out there. I know that all the universities in Glasgow, where we're, as you know, we're based, crank out people who know Java. It's taught at undergrad. So I just need to go to careers fair, identify people who are motivated and smart and want to make a difference in government, and hire them, put them in seats, give them what they need, and suddenly they'll be able to contribute to the systems. What I'm concerned about on the flip side is I don't really see how I can do the same thing with Clojure. There's, I looked online for surveys of language usage and so on, and there's many, many, many more Java developers than Clojure developers. And for me, that presents a risk, because what I don't want a system that is really, really maintainable and elegant in theory, but in practice unmaintainable because no one with the skills needed is available. So I don't know, what kind of strategies should we adopt to hire for Clojure?
So I think there's two things here. You have internal hiring and you have external hiring. And really what we need to embark on the transformational journey that you've said you want to embark on is you need to bring people within the organisation along on that journey, as well as pull in external expertise wherever possible. Now, you have a fantastic team internally, and I'm really pleased to see that you've been spending time on bringing people on that journey who are interested and not just being a top-down drop of new information and new tools that they really weren't interested in. In terms of the transformational change, you're right. No one would deny there are many more Java developers out there, and Java developers range from fantastic, incredible developers right down to people at the very opposite end of that market, unfortunately. So it's quite a wide range, and it can be challenging sometimes, even with Java, to find the right people, and especially who can come up to speed with the design patterns and so on that are already in your code base. You look at Clojure as a language, there are many fewer Clojure developers out there. However, they tend to be people who want to keep on top of the latest changes and developments. They're really quite self-motivated people. That's not to say they're all good developers. We can't ever promise that. But I think you'll find these types of people by going along to the local meetups and by publicising what Student Loans Company are doing and the technology you're adopting. And that will naturally attract, albeit fewer people, some really good people that you want to get within your organisation. And remember, just because there's fewer developers, there's also fewer people recruiting for Clojure developers. So perhaps you can take advantage of that.
All right. So let's see what our colleagues thought of this. So we asked them whether they agreed more with the statement that using Clojure makes it easier to hire a good team because as a language it attracts programmers who are motivated and engaged. On the flip side, we offered them the alternative that using Clojure makes it harder to hire good developers or good teams because there are less Clojure programmers than Java programmers. And we have much more of a dissenting voice in this question. But still the majority believe that using Clojure makes it easier to hire a good team. Now, in retrospect, there is a little bit of a structural bias here because the people we asked are those Clojure developers. So it seems that 70% of people agree that they are awesome. Perhaps actually the question is about the honesty or the feelings of the 30% of people who didn't go with that. But I think it is a genuine concern, right? This is not something made up. It's not something that people who are custodians of large systems are being unduly paranoid about. They do need to worry about this in the long term, but based on the opinions of the people who are close to this project and who have been able to see over the long term as new people have been hired for student loans and seen people inside student loans grow and flourish adopting a new technology, that on the balance it was something that was good, not something that was bad.
Some key quotes that come out. Hiring Clojure developers is not easy, and upskilling your existing devs to write Clojure is risky. Yeah, I think the upskilling point is something we've perhaps not spoken about yet, but it is very important. There are anyone can write Clojure code. Not everyone can write good Clojure code. That's a very different thing, and there is a bit of upskilling has to go into moving from the object-oriented paradigm to the functional programming paradigm.
And another thing that someone said that I thought was quite fair is that it's harder for SLC to recruit programmers who are motivated, engaged, because they're not well known for using a new tech stack. So this is where we get a chicken and the egg problem. So we have an agency in government who's doing really vital work, and they're not known for being as adventurous as other businesses in the city, and that's probably not that surprising. But to use the fact that you're not known for being modern at the cutting edge of technology to not go to the cutting edge of technology actually possibly in the long term is a trap. And I know there was a quote in this morning's keynote about NASA. It was actually taken from Sarah Jong, I think, which was that the riskiest thing is to do nothing, right? To take no risk is in itself very risky itself. So there kind of is no easy way to, in the long run, play conservative, because conservative strategy of technology is in itself risky in its own way. All right, scene 4, syntax. So this is the real drama in any talk about Lisp. Okay, so Gary, we've talked a lot about the tech and the people, and that's really useful. I think you've given us some food for thought, certainly. But as part of the due diligence, which it's my responsibility to exercise, I had a look at some code actually, and it seems a bit weird. So Java, C++, C, JavaScript even, they all use the same tried and tested way of writing code, right? You have the curly braces, you have the semicolons. So anyone who knows one of those languages can look at another one and they can find those semicolons and those curly braces, and that tells them what's going on. Lisp, on the other hand, everything is just the same. It's like parentheses, and like at the bottom of some functions I saw 5 or 6 closed parentheses in a row. And it seemed just a bit odd to me. So I'm worried as someone who has to think about the organization as a whole and people moving around from project to project, and we will continue to have Java and JavaScript work for some time, regardless of the decision here. I'm just thinking about what this might mean for my ability to move resources, around from one project to another. If the syntax just makes it a real barrier for them to get going. Why should we go with a technology that just puts this kind of gratuitous blocker in the way of people becoming productive on a new project?
It is different, Chris. Yeah, it's the Clojure syntax is different, and some people take it really easily. Some people find it more challenging. It's a personal thing. And this is why it's exceptionally important to take people from your organization on a journey with you over transformation and not to force it on them. For some people, syntax would be the camel that breaks the straw that breaks a camel's back. The reality here is not a particularly difficult thing, and Clojure gives you many of the tools to work with this. So for example, in Clojure, we work regularly with what we call a REPL, a read, evaluate, print loop. It's essentially an interactive command line where you can execute code and get immediate feedback on what you're doing. But it's a fantastic place that you can go to try out the language and explore libraries and see how they work without having to worry about compiling your code. You get really fast feedback. In terms of tooling, for your Java developers, if any of them are using IntelliJ or similar types of IDEs, IntelliJ has a plugin called Cursive, which is fantastic support for Clojure, and it helps you with all the structural editing that might initially be a challenge to get over. Many other IDEs have great support as well. You look at Emacs, you look at Vim. I don't think there's any shortage of options to help people, but you do need to ensure people are engaged.
All right. So we put this question to our colleagues as well. So we asked them whether they felt that Clojure's Lisp syntax makes it easier for newcomers because it's consistent. There's not many different things to learn. It's just open paren, close paren. On the other hand, we offered them the option that Clojure's Lisp syntax makes it harder for newcomers to learn because it's so different to Java. And at least in the context we're in, a lot of the people coming to Clojure were coming from Java, some from JavaScript as well. So the results, as you might expect from something that is a notorious bike-shedding topic, were split 50-50. So some people did really like the Lisp syntax, and I've grown to see code in that way, and I really enjoy working with that. Other people just felt that it wasn't really what they wanted to do. So I guess there's a couple of things you could take away from this, or two interpretations. One is that it's actually a matter of intense argumentation, but on the other hand, I think actually in the context that we were in, it wasn't a killer thing one way or the other. So the syntax feels like a really big barrier to Clojure and Lisp at first, but in our experience, it wasn't that big a deal, either positive or negative, frankly.
But then other people might have a slightly different feeling on that. So if you consider newcomers to also include those new to programming altogether, so that's an important point. Who is coming to Clojure? Have they never done any programming at all? This will probably be quite easy for them because we tend to forget how high ceremony object-oriented languages are. You know, it does take years to build up the knowledge and the depth of knowledge to be able to effectively use all the design patterns and all the scaffolding that's required to make Java effective. You simply don't need much of that with Clojure, which is why the solutions that you build with it tend to be many less lines of code. And we all know that less lines of code means less bugs.
But you can see that, you know, some people, for example, said, I just don't like Lisp syntax despite its advantages. So the intellectual argument was made to them, but just in the end, it wasn't something that was to their taste, which is unarguable. And someone made the subtle point that the syntax is quick to pick up, quicker than your standard OO languages. That was their perspective. So I guess there's the fact that there's less of it might mean there's less to learn. And I think for me as an advocate of Lisp syntax, one of the nice things is that many of the things in the Clojure language are actually built in Clojure itself. So the for loop in Clojure, or the for comprehension, is a macro. So it's built out of Clojure. So if you want to know kind of how it works or how it's put together, in a Clojure environment, you can dig down and see what that actually means. You can't do that with Java's for loop. All right, scene 5, immutability. So Gary, thanks for catching up. There's a question I have. It might be a stupid question, because what my understanding now doesn't really make sense, but it's something I really hope isn't a blocker. So Clojure's data structures don't change, as I understand it. So you make something, for example, like a record of a course or student record, and then the language itself prevents you from changing it unless you jump through these hoops. So I know there's workarounds with, like, I know, recursion or weird stuff, but it seems like this is an unnecessary barrier. So here at Student Loans, a lot of what we do is we're not making a platform as a service or anything like that. What we've got stuff in a database that's record of data, that's important data. We lift it out of the database, we put it on a form, then people edit it, and then we put it back in the database. So basically our whole business is taking a data structure, changing it a bit. So I'm just not sure whether a language that apparently is built around the idea that you can't change your data structures suits our use case. So why should we pick a language that appears to be against changing data? I guess I just don't really get it.
So object-oriented programming has been around for a number of years now. When people started focusing that in the latest and greatest thing, probably off the back of one of the conferences you mentioned, there weren't many users of a system at a single time, and they weren't doing multiple things. Concurrency now is massive. You know, every system you ever work on will have many, many users doing many things at the same time. Another example of that, and where that becomes important, is when you consider Moore's Law. So Moore's Law has been telling us for many years that the number of transistors on a chip is going to double approximately every 2 years. However, we're gradually approaching the limits of physics. We can't continue to double at that same rate. So what that means is, if we want to continue scaling, one of the obvious solutions is to put more chips on our hardware. And that means we have to get good at concurrency. Now, immutability is one of the things that makes this very easy, because shared mutable state and the state that you commonly find in your object-oriented software are one of the core areas where you find bugs. I mean, how many times have you, probably in student loans alone, found, say, for example, race conditions? And heaven forbid it's a race condition that happens once every fortnight in a production environment. You can't replicate it in a development environment or anywhere else to actually troubleshoot what's going on. Often these types of bugs come down to data that is changing under your feet. Now, core to functional programming is immutability. And that concept of immutability does take away many of those challenges. But it does require a different way of thinking. And there is going to be a learning curve and a ramp-up time for anybody that wants to come from the object-oriented paradigm across to embrace immutability. But I would also argue that immutability is also an important concept in Java, and it's been more and more recognized all the time. So perhaps, with your developers getting involved with Clojure, they'll actually become better Java developers.
All right. So immutability, one of the big trumpeted features of Clojure. So to be clear, if anyone isn't familiar enough with Clojure for this, all of Clojure's data structures are, all the different fields are like they're final in Java. So unless you jump through some very specific language hoops, the way to alter a piece of data is to write a function that takes in one version of it and produces a new copy, which is the new version. So no setters. So in the case of the survey, we asked our colleagues, do Clojure's immutable data structures reduce the number of bugs? Or did they instead more agree with the statement that Clojure's immutable data structures force us to write our code in weird ways, unnecessary?
Here's a big drum roll moment.
All right, so immutability for the big win, according to our pseudo-scientific data. So people definitely, overwhelmingly, but not to unanimous levels, thought that the immutable data structures reduced the number of bugs. They liked that. It wasn't, even people who were maybe otherwise skeptical of functional programming quite heavily came down on the side of immutability as being a good thing, not something that was awkward or a disadvantage at all. And I think actually one of the interesting things when we were putting this talk together was how often the things that we discussed as being the advantages to Clojure were also things that some people were conservative about. So a lot of the things, people don't really disagree about what Clojure stands for as a strongly opinionated designed language. It's actually the value systems and their perspective on it that changes as to whether they like it or not.
And immutability is something that, I've bought into for a long time, but the thing that really drove this home for me was at one point we were working on the project and there was a big flurry of activity from senior people. They were panicked because they heard that there were 3 bugs that needed considered in the system that we were building. Now, I've unfortunately, not proudly, been in projects where there have been backlogs to handle the bugs. It was quite fantastic to be in the position of, there being quite a lot of furore because there were some bugs. Now, I would highlight, we did, as I said already, have a very strong team. How much of that comes down to just the skilled individuals that we had there, I don't know. And I'd also point out that the 3 bugs that were around at the time, I'm not 100% sure they actually came down to code issues. It could just have been requirements gathering and so on. But the reality is we went through that project. We went from kickoff to first deployment to production and use by users within 6 months, I believe it was. Sure. And we rarely had bugs.
I have to also say, maybe you're not aware of this, Gary, that the fact that we had 3 production issues actually caused a little bit of a storm within people whose job it was to track the bugs because they felt that we must be concealing them. So compared to some of the comparable launches they'd made with different technologies, this was actually quite, maybe 2 orders of magnitude different than what they were expecting based on their existing context of other things that hadn't gone so well. And so it was felt that there must be more. It's just that we weren't really recording them properly. Fortunately, we were able to demonstrate that that wasn't the case.
We never recorded bugs if it had my name against the commit.
Oh, exactly, yes, something like that.
Okay, some comments that come out. The hardest thing is to try and get Java devs to stop thinking OO and go through the paradigm shift to think functionally. And that, for me, is an important point. And I think it's also a good reason to pick Clojure over some other options such as Scala, because you can easily just start writing Java in Scala, whereas there is a very clear shift towards closure. Now, that doesn't break the mindset, but it does put a real line in the sand. So yeah, I think that is one advantage of closure. It is significantly different from Java, and that can be beneficial.
And we should emphasize the second quote as well, which is I thought very fair, which is that despite the benefits of immutability, you can still produce an unholy mess in Clojure. So none of these features get you out of the responsibility of designing. In fact, maybe actually Clojure puts more responsibility on you to design what's going on. So no free lunch, no silver bullet.
So we have 2 scenes to go. Scene 6, Interop.
All right, so one of the things that I know I'm going to be asked about, Gary, if we adopt Clojure is, what about the existing investment we've made in other technologies? So we've got a lot of Java code. I know, probably a little bit too much, but it does valuable things. It's, millions and millions of pounds have flowed through the system, jobs got done, we've paid for it, we've paid wages, we've got all that investment sitting there. And I'm quite nervous, frankly, to go before the CTO and say that we just don't want that investment. We're just kind of like writing it off. We're not looking at it. We're going to go to a completely new language, and Java is no longer something that we care about. And that applies, by the way, not only to the code we've written, but all the good code that has been written in products and open source libraries and so on that's in Java. I don't really understand how I can defend this to the business when I say that we're going to get rid of that investment. We're just going to move to a new stack and leave the old behind. Have you got any pointers for me, frankly?
Yeah, naturally, from a business perspective, previous investment has to be core. And you look at Clojure, it runs on the JVM. All your previous infrastructure investment, your investment in tooling, your profile tooling, and all those different practices that you have there, that doesn't go to loss. And the same is said of code level dependencies and Java libraries. The interop between Clojure and Java is actually really good. You absolutely can call into any Java code from Clojure. I would highlight that possibly it's not always the best way to do things. You can reuse those libraries, but sometimes there are more closure-y ways of doing things that perhaps you'll find less resistance with. For example, when you look at configuration, there can be quite significant differences between how you would handle configuration in Java versus how you would do that in Clojure. However, the interop is fantastic, and you're not going to have to throw away any of the investment. And I'd also outline that Lineagen, the build tool for Clojure, allows you to manage dependencies, and ultimately it's Maven under the hood. So any Java dependencies, any Java jars that you have dependencies on, you can make sure are in there, and you can just consume from within your code.
All right. So we did use Interop on quite a few occasions on this project. So did our colleagues think that using Java libraries from Clojure is convenient and saves a lot of time? Or did they instead think that using Java libraries from Clojure is convenient but suffers from impedance mismatch in the long term between the two kinds of language? And this is actually a little bit split. So when I first learned about Clojure, I thought the interop was just such a massive win. And it is really convenient to be able to call a Java logging library rather than writing your own. But you can see from this that it wasn't as big a win or isn't as important in the long run as you might have imagined.
Yeah, absolutely. And it just strikes me just now looking at the numbers there, we haven't done any comparison of who's come from the Java background and was worried about this and therefore fits in the category of wanting to reuse those libraries, or who comes perhaps from more of a functional Clojure background where they're quite keen to rewrite things and do things in a more Clojure way.
I mean, to be clear, it is useful because it means that you're never going to be trapped. But in the long run, we often found ourselves preferring versions of libraries that have been written in Clojure natively with Clojure design expectations in mind. In particular, ones that involved interacting with the outside world. So Java libraries that could kind of be seen as pure functions, generally fine. Ones that involve configuration or I/O, that started to get a little bit more hairy in the long run because they were written with different kinds of design priorities in mind.
So this isn't an accidental empty slide. Nobody passed any comment whatsoever. They answered, it was a split vote. Nobody really had anything to say. I don't know how significant that is. Might be, might not be.
Maybe just interop is not everyone's passion.
It's not too sexy.
Cool. All right, so this is the final scene. So, okay, Gary, you've done the due diligence. I understand you've made this argument. I think we are ready to try closure, but one of the things I do want to stress is this isn't just an open the floodgates moment. Like, you've gained a lot of arguments and so on, but as part of the risk management that I need to do on this project and with this architecture in general, is that we need to try something out before we commit fully. So we are clear to let you use closure for this instance, and then after that, what we want to come back and have a look at how it went and what we should do in the future.
I'm absolutely over the moon that you want to take that approach, and I think it's a sensible approach. You mentioned at the start that you want to be a good steward. I would never advocate a wholesale replacement, but to take something and try it out in a small, isolated location and then start to grow that organically within the organisation, I think will give you a lot of the tools for motivated teams, new learning, and really moving towards that position of reputation that you want to have.
All right, so this is the question we promised you at the start. So, do closure's advantages in the totality make it worth introducing into a traditional Java environment? Or on the flip side, did our respondents more agree with the statement that closure does have some nice features, but it's a little bit too much to introduce into a traditional Java environment?
So we're not going to ask you all to stand again or go through any of the drama there. What we'll just do, we'll show you the numbers. It'd be great to know, maybe a show of hands after this, if anybody has been influenced in any way. And if you have been, it would be great to talk to you afterwards. But here we go, the big punchline moment.
Okay, so of the people who worked on the project, a large majority did feel that using closure in this Java environment, the benefits of it did outweigh the negatives. But that's not unanimous. And I think there was a decent proportion of people who, even though they'd been exposed to closure for a decent period of time and they'd seen what it can do, still had a little bit of a kind of a negative feeling towards it in the totality. So certainly something to think about when you are adopting something like closure environment is make sure that you do your duty to the skeptics. Make sure that you do think through all the decisions that you're making and make sure that you address the kind of valid concerns of people who are not maybe yet bought into closure, because if you don't, you are going to end up with resentment, and if things go wrong, which they do on every project, then you're going to find yourself kind of defending the language, and it's going to get a little bit messy.
So some final quotes. Success is dependent on the mindset of the people, the environment, and the culture they work in. You can't throw a new language, a new set of tools, or anything at people and expect it just to magically work like the silver bullet you open with, Chris. This is a journey, and it's a journey for everyone. It's the technologists, it's the organisation, it's a business. You have to be aware of that, and you have to make sure that the right people are included and that they really want to be included.
Cool. And on the flip side, someone did comment that higher order functions, I guess the kind of thing that closure excels at, requires a levelling up in abstract thinking that some will find hard. So certainly if you've been working in Java for a long time and had that way of working in objects, switching to another paradigm is tricky. So certainly, even if you are like me, are convinced that closure is a great thing to try in environments like this, it's not a matter of just instantly flicking on the closure switch and everything's kind of different and okay. You do have to think about the people who are coming across with you and giving them the right support, and actually just also, I think quite importantly, capturing their imagination. To do something like closure, which is a new technology that's a new way of thinking, involves a lot of learning. And that's pleasurable to a lot of developers and probably a lot of people like yourselves who come to conferences. But it also is a demand on people, and if they're not engaged and they're not passionate about it, then they probably won't put in the effort, understandably, to really master it.
Final conclusions. Chris, would you do it again?
Yes, though there are things I would do differently. And probably one of the big things I would do around the kind of discussions that we talked about is I would try to do a better job of explaining to the client the full implications of what it meant, for example, for kind of the training and what also the advantages in the long run. Because I think at the time, because it was such a high priority project and that was the key, we talked about deadlines a lot, which we met. But I would probably try to do a better job of engaging with the architects, like the people I was speaking, and making sure that they were fully aware and fully bought into all the long-term effects of what we might do.
I would be in exactly the same category. I absolutely would do it again. I would push for closure anywhere I go, assuming I felt it was the right tool at the time, and a lot of occasions it is. I think something to bear in mind is I think it was Fred George said yesterday that for many CTOs, they would rather stick with the cookie cutter shape of how things are done, because if it fails, then they don't get the blame for breaking the mold. This is risky, and you have to be really confident and strong, because it might fail. You know, it could go wrong, it could blow up in your face, and you have to be able to live with the consequences of that. So you have to be really strong and confident and approach it with that open mindset. But if you do so, I think it's fantastic. Final comment, please do rate the session. And thank you all for attending.
Cheers.
So I have a few questions from the audience for you. One that I wondered about myself was, what was the size and type of developers of that particular team? I've tried to figure it out from the percentages, but I was too dumb to do so. Was it like, and what type? Was it senior, junior, seasoned Java developers?
Well, I think all up, we, depending on the stage in the project, had between 3 and 5 pairs of developers working. Would that be fair?
Yeah, there was one point, I think, where, and this comes back a little bit to our thoughts at closure, small teams you gain from and big teams you don't, is at one point there was a tough deadline, and unfortunately there were some powerful pressures to add more people. So it did grow, I think, considerably bigger at that point, but that causes problems. But it would cause any environment problems.
And I think in terms of the makeup, we had a relatively junior team, I would say. So people who'd been working for maybe 3 or 4 years as developers, mostly of them ThoughtWorks, combined with some people who'd been doing it longer. And that actually was something that played both well and badly. So it played well in the sense that here were people who were really interested in learning new stuff. So they would come with suggestions, they would investigate stuff in their own time, they would really get into it. On the other hand, that meant that when we were talking about design in this new context, we had to work harder to support the people who had less experience in coming up with really strong designs.
Yeah, and one final thing I think is it's worth noting that we did start with predominantly ThoughtWorks staff, and then over a period of time we switched over to being predominantly student loans. So it was a blend. It wasn't that we took the client into the deep end and expected them to sink or swim. We did have a lot of experienced people with some functional backgrounds, and then we gradually tapered that through time.
Another question was, do you think it's easier to take a postgraduate student and have them learn Clojure? Will it be easier for them to train them in the Clojure way of doing things, or is it easier to do it with a seasoned OO developer?
That's an interesting question. So I remember teaching Ruby to people who were very smart and who never learned programming before. And there was one person who got stuck for the whole lesson. And it was only at the end I realized it was because they were confused about how plus worked, because most of the methods in Ruby followed the pattern that everything else did. You do object dot method, and in this case plus just goes in the middle for no apparent reason. So to me as a programmer, I knew that plus in the middle was something that we expect by convention, nothing about the universe. So I think had that person, who was kind of a smart graduate, been shown Lisp, they wouldn't have hit that because there would have been that consistency. So I actually think from someone starting from zero, I think it's easier to learn Clojure than Java.
Mm. Yeah, something else I'd like to call out from that question, and maybe this isn't intended, but the use of postgraduate there. Yeah. I'm not convinced we always benefit massively from looking at graduates. You know, there are a lot of really smart people who leave school. I think you could sit down with a language like Clojure where you get to really focus on the logic and really get some fantastic things from them. So yeah, I don't know how much that person intended the postgraduate part of that question, but you know, maybe we don't need that at all.
Yeah. And there is actually a third group that I'd like to mention, which is JavaScript programmers. So there is I don't know to what extent this is true, but apparently the original version of JavaScript was a Lisp. And then they dressed it up with the syntax of the semicolons and the curly braces to make it more marketable. But whether or not that's true, there is actually a lot of truth in the idea that the way of doing things with callbacks and first-class functions in JavaScript actually helps you a lot with Clojure. So in some sense, it might actually be easier to move from JavaScript to Clojure than from Java to Clojure.
Maybe a final one. I'll actually have to make it easy for me to merge about 3 or 4 questions into one. Would things have been easier if you'd picked a statically typed language?
On some occasions, and it possibly pains me to say this, yes. So one of the big things we ended up using, and it's quite in big use in the Clojure community, is something called prismatic schema, which is a framework for defining schemas of data structures. So Clojure uses JSON, kind of, as its data structure. So overall, I definitely think that the type decision on Clojure was the right one, but there were points where, in terms of fitting our design together at the big level, because we didn't have static types, we ended up using contracts instead. So there is something you can easily fall back on, as we did, but definitely the sprawl of data structures, when you can do anything with them at all, and you can just put together a JSON representation of a course or a student or a term, that was something that we should have kept more of a lid on. And in retrospect, I wish we'd followed like Alan Perlis's advice about having, one data structure and 100 functions. Because the thing that we did wrong, I think, was we had a lot of different variations of data structures representing the same kind of data. So as we started to build like a course record from basic parts and do different things to normalize dates and validate, that meant that across the flow, the kind of the function pipeline, we had different points where there were different things present and missing. And that, I think, was actually a bit of a tricky thing for us. So had we been more disciplined about thinking about our data formats first, which is kind of the Clojure way, and thinking about exactly what that meant, and making large numbers of functions depend on those few and well understood data formats, then I think that would have gone really well. As it happens, we had to occasionally kind of do some cleaning up because of those proliferation of data formats.
I think another thing that possibly muddied the water there as well is we also chose MongoDB as our as a repository, really. So you had obviously a kind of schemaless database, and then you've got a lack of types in your code, and I think that probably further influenced the prismatic schema stuff being smattered at one point across the code base. So really you've taken something that a database is good at and you've distributed it throughout your code base, which I'm personally, I'm still out in terms of, I like some of the flexibility, but then the prismatic bottleneck, maybe it could have been done differently, or maybe there wasn't a good selection somewhere along the line. I don't know, it's hard to say.
Okay, thank you very much for this great talk.
Thank you. Thank you.